All right, chalo. Let's get into it then. Yeah.
Adu.
Okay, let's look at this example. We saw this earlier also. 3 younger kids, 10 chocolates each. 3 older kids, 20 chocolates each. So each older kid gives 5 chocolates to each younger kid. Or another way to think about the same thing, the difference between older and younger kids, the difference of 10 chocolates gets split evenly, half and half. Why half and half? I mean, now mathematically, because equal number of kids at both places. So in a ratio of 3:3. Each kid is giving half the chocolate, half of the difference to each kid from the other side. There are 3 kids on this side, 3 kids on that side. So there's 1-to-1 mapping. That's why the difference gets split evenly. Now, let's figure this one out. Tell me, what would be the average in this case? So how do we calculate this 30? Again, I don't want to get into the formula, but think of it this way, that overall, let's say we keep 10 chocolates with everyone. These 6 kids have 30 extra each. So overall, there are 30 into 6, 180 extra chocolates. Extra how? The smaller number 10, I let everyone maintain 10. Whatever is extra beyond 10, I take those. So the 6 kids have 30 extra chocolates each. Overall, 180 extra chocolates. Now, these 180 extra chocolates need to be distributed among the 9 kids, all 9 of them, not just the 3, all 9. So then each of the 9 kids gets 20 more chocolates. They had 10 earlier, they get 20 more. Overall, each one ends up with 30. So yes, in this case, the average is 30. Now, already what we are seeing here is actually what is weighted averages, right? The weights are different. But I mean, while even I will use this terminology, but these things can be understood still at a very, very logical level. It's not a formula that I just need to memorize and then blindly apply. All right. Let's try this now. Let's say there are 3 kids with 10 chocolates each. There are some kids with 40 chocolates each, and the overall average is 30. Now, I don't want you to guess the answer. Basically, the figures I've kept exactly the same as the previous problem. So the goal is not to somehow just guess the answer here, but to try to figure out the answer. All right, let's take a look. So there are some kids with 10 chocolates each. There are some kids with 40 chocolates each. How many kids with 10 chocolates each? 3. And we have to figure out how many kids are there with 10 chocolates each. 40 each. What I know is that the average is 30. So let's deal with this side first. These kids have 10 each. So there's a shortage on this side. How much is the shortage? Remember, after the chocolates are evenly split, then everyone should end up with 30, 30, 30. So these 3 kids on the left have a shortage. What's the shortage? Each kid has a shortage of 20. And there are 3 such kids. So overall, the shortage on this side is of 60 chocolates. That's the shortage. Tell me, anyone unclear about this? I'm not done yet. I just figured out the shortage. Now, whatever is the shortage on this side, that's the extra on the other side. That's how overall it'll get balanced. So that means the extra on this side has to result in 60. Now, each kid has how much extra? 10 extra, right? 40 compared with 30. That's 10 extra. 10 extra each. So what do I multiply this by to get 60? 6 essentially, right? That tells me that the number of kids with 40 chocolates each would be 6. Tell me, if that's clear, let me know in the chat. Clear? Yes? No?
Uh, Anish, I had a question. Uh, s- can I ask you right now? I can't hear you.
Yeah, go ahead, Namita. Go ahead with
Yeah.
your question.
So I actually solved it in a different way because so I actually did the usual way how we would put the formula for an average, because I thought like if we do it in the chocolate method, it might just take a bit longer as compared to. So I did 30 plus 40x upon x plus 3 is equals to 30, and that's why I just got it quickly. So is that okay in that aspect?
See, this is a very simplistic question. So sure, using the formula would have been faster here. But then the goal is that we get comfortable with this approach so that maybe we can use it on more complex questions where then it would be more, it will save time actually. No, so
Sure.
nothing right or wrong, but at least now is it clear how we got 6 this way?
Yeah. Yeah, it's clear now. Thank you.
Sure. और बताओ questions? Okay, let's continue then. Let's try this now. And in fact, this time, let me say, everyone try using this whole chocolates thing that we've been discussing only. So what do we need to figure out now? We know 3 kids have 10 chocolates each. We know the overall average is 30. The question is, how many chocolates do the other 6 kids have each? Walk me through it. What approach did you?
So basically 3 kids with yeah, 10 here and let's say X there, and yeah, and then 3 here, 30, and then 6. So I did the same thing that we did in the previous one. Shortage is uh, the shortage on this side is 20 for each, so that's 60. And so the shortage of 60 is here on with three kids. Here the excess of 60 is amongst 6 kids. So it'll be 10 extra for each of those. So it'll be 30 plus 10 there. So 40 for uh those ones.
Yeah, yeah. This last thing to remember is very important, that this 10 each is the excess. So the figure then becomes 30 plus 10. Yeah, good. Right? That's how we get 40. Nice. So many times in questions related to averages, basically overall there are these 5 pieces. In, for example, here, number of chocolates that one set has, number of chocolates that the other set has, number of kids in this set, number of kids in the other set, and the overall average. So they can anyway give 4 out of these 5 things and ask us to figure out any of the 5th one. Right? That's one format of questions. Also, there is a relationship between the number of kids. And I will talk more about this, but basically, even if, let's say, the number of kids changed from 3 and 6 to 30 and 60, even then this figure would remain 40. Again, this is, while many of you might already know this mathematically, that, oh yeah, it's the only the ratio that matters, but exactly where it comes from, I will try to explain that also. And Abhinav, how did you go about it?
So Anish, the average was 35, right? Which was a 3 in excess. I mean, if you see the average of men, right, which is 38, which is 3 more than your the overall mean. So that 3 has to be distributed between the 26 women, which is excess of I think 2.5.
Nice. So you applied this in the morning also?
Yes, correct.
Okay. So what do we have here? 35 is the overall average, which I will put right in the middle. Men's average is 38. Women's average I have to figure out. What else do I know? There are 22 men. There are 26 women. So these are the numbers. These are the ages. So again, ages can be thought of as chocolates. Numbers are anyway numbers only. So then 38, there's an excess here. So one thing that anyway becomes clear to me right away is that this number will be less than 35. Doesn't help with the options here, but still, right? Women's figure will anyway be less than 35. All right. So in terms of excess, each man has an excess of 3 years. Overall, there are 22 men. So the extra portion becomes 3 times 22, 66. And then the shortage on this side will also be 66. And that's among 26 women. So 26 times each woman's average age will be 66. So that average age per woman will be 66 upon 26. Now, how do I deal with this? I find one extremely, what's the right word? Not used enough, less used form of numbers are mixed fractions. So if I were to convert this number into mixed fractions, 26 times 2 is 52, sorry. So 52, and then the remainder is 14. 14 by 26. Now, if you look at it, 14 by 26 is very close to 13 by 26, which would be exactly half. So this number also is roughly half. Remember, the question is asking for which of the following was closest to the average age. 13 by 26 would have been exactly half. This would be slightly more than half. Anyway, the only two options with decimals are exactly 0.5, 0.5. So I'm not too bothered by that. Now this is the short minus 2.5. I get 32.5. That's the answer. All right, so that's this question. Let's continue. Here's the next one. Okay, how would we calculate the average? What?
Total by number of days.
Total revenue divided by number of days. Okay, in a retail store, the average sale for month M was $D. So this means average sale per day.
That's what I assume.
Okay, this is interesting. Or kya? Let's see. What did others think of this average? What does this average even mean? So one thing Kanav has mentioned is that it's the average revenue per day. Anyone else took any other interpretation?
No, Anish, actually, I just compute the percentage difference. I haven't thought of number of days and all, because we are comparing 2 months.
Therefore,
we can just look at the percentage difference. If it is 20% higher, then I'm good.
okay, all right. So, okay, let's get this out of the way. First of all, is the first statement alone sufficient? For month M, the total revenue was $3,500. I don't even know the revenue for month J. So anyway, what's the increase and all? No way of figuring that out. Right? Statement 1 alone not sufficient. Same issue with statement 2. They've told us about month J, but not about month M. So the second statement alone is also not sufficient. That much is at least done already. All right, so the two statements independently are not sufficient. Now, one question becomes, what is this average, and can I just ignore the average and straight away look at the revenues? So when we combine the two statements, then sure, the percentage increase in revenue was from 3,500 to 6,000. So what's the increase? 6,000 minus 3,500 divided by 3,500. So this is 25 upon 35. I don't care what the value is. Anyway, this is more than 20%. That much I can see. So since this revenue increase is more than 20%, can I say that the average sale for month J was at least 20% higher? For that, again, the question becomes, what does it even mean? Remember, the two statements are talking about total revenue, not the averages. It's a retail store. So how would you calculate an average sale? So that becomes the question. So first issue is that, can we ignore the average altogether? No. We have to figure out how the average and revenues are related, what's going on there. Can we just directly look at this difference, see that, oh, the revenue has increased by more than 20%. Therefore, the average sale would also be more than 20%. We don't know that. Right? So if you decided that the combination is sufficient based on this much, that's an issue, that's an error. This much is not enough yet. I have to figure out what this term average sale means. Now, average sale. What do you think? Could average sale be average per day? No, it's a retail store. I'm thinking total revenue divided by total sales. That would be an average sale. Sales basically how many transactions have been done. So revenue divided by number of transactions. That's average sale. And next, do we know how many transactions there were in the month M? Do we know how many transactions there were in month J? No. No idea about that. That's never been discussed. And that's why even the combination is not sufficient. The answer to this question is E. The key was understanding that average sale would be revenue divided by number of sales or number of transactions. Enough? Does that make sense?
Yeah. Thanks.
Remember, the full term is average sale. It's not just average in isolation.
Yeah.
Okay. Let's try another one. Go ahead. Let's discuss this one. Now, quite a few new things have come up here. We're looking at percentages, 2 items at one discount percentage, 1 item at a different discount percent. And the question is, what's the total amount of the 3 discounts greater than 15%? So one question coming to my mind is, wouldn't it simply be that, oh, we have 20% discount on 1 item, 10% discount on 2 items, and then just we find where the average will lie in the middle? the way we used to do with chocolates and all. One kid has 20 chocolates, two kids have 10 chocolates each. So we want to distribute them evenly. Overall, there are 10 extra chocolates or 10 extra %. They get distributed among 3 people. So then each one gets 3 1/3, 3 1/3, 3 1/3. Overall, everyone ends up with 10 plus 3 1/3, 13 1/3%. And then, was the total amount greater than 15%? The answer becomes no. Shouldn't this be the way to deal with this question? One issue, if I do this, one issue is that, hold on, are we saying then that I have figured out a confirmed answer for the question without even looking at statements? Now, what option would that be? That I don't need either one, but I have the answer. That's no option out of the 5. Right? So that's one red flag that maybe I've made a mistake somewhere. So no, this is not how I would calculate the overall discount percentage. So then the question becomes, okay, if not like this, then how? For that, let's just take a moment to understand what might be going on. How would discounts be calculated? What might be going on? So think about it. Let's say you buy one car and a very expensive product at 2% discount. And you buy one pen, a very cheap product, at 50% discount. So does that mean overall the discount is 50 plus 2, 52, 26%? Overall on the 2 purchases combined, have we got a 26% discount? Let me have a conversation with someone. Namita?
Yeah.
What do you think?
No, it's not 26%.
26% sounds too big, right? So if overall it was 26%, then basically the dollar amount of my discount would have been much higher than what I actually got.
Yeah, so essentially, I think we would have to know the cars and the pens actual amount to derive the
Right.
cumulative percentage.
Right. The price of the car and the price of the pen. Yes. That's what would help me figure out the discount percentage. Indeed. Number of cars and number of pens doesn't work. Think about it. Overall, now I'm saying, oh, I've got a 26% discount. So let's say the car was 10 lakh rupees and the pen was 10 rupees. So 26% means I've got 2.6 lakh rupees discount. And plus, whatever, even 10 rupees doesn't really matter, but overall I've saved 2.6 lakh rupees. Versus 2% meant I've saved 20,000 rupees. Right? So, world of a difference. I won't calculate the average discount this way, just by looking at number of items. For that, we need the prices. Indeed. Tell me, anyone unclear about this? That to figure out the overall discount, what I care about really are the prices, not the number of items. So many times in average questions, the issue becomes essentially, what are the kids? What are the chocolates? Right? Here, for example, okay, I have to figure out the average of these percentages. That much is clear. So chocolates are the percentages. But now, what are the kids? Kids are not the number of items. Kids are the prices, essentially. Those are the weights, the technical term. So let's do that now. number of items doesn't matter. What matters is that there's a 20% discount on the most expensive item, right? All I know about this is that this one is most expensive. And there's a 10% discount on two other items which are less expensive. What I don't know here is the overall price. What I care about is the price. How many items that price is spread across doesn't matter. Whether it's just one item which is less expensive or two items, 3 items, 10 items, doesn't matter. What matters is the price. Now, one thing I'm mindful of at this time is that while one item is the most expensive items, but these two combined, this price may be more or less than the single item's price. Right? This is the price of two items combined. So about that price, I don't know anything. I know each item is less than the most expensive item, but when I add up two such items, where do I land up? Don't know. We could have something like, for example, this one is 5, this one is 4, and one is 3. So 3 plus 4 becomes 7, more than 5. Don't know that. The question is the overall discount percentage more than 15? In other words, is the overall average more than 15%? How do we go about it now? Let me deal with the second statement first. That one looks easier to deal with. The regular price of the least expensive item was $15. Fine. So one of these was $15. But I don't know this one. I don't know this one. Basically, I don't know how the two prices will compare. The price on the left, the 20% discount, and the combined price of the 10% discount items. If I were able to figure out the prices, how would they help me? Or rather, let me ask you this way. In what circumstance would the overall percentage, average percentage, be greater than 15? When would that happen? Namita, why don't you help me?
But I don't know how do I say that basis the second statement, because we don't have any
No, leave the
information.
statement. I'm just asking you a general question. When would this percentage be more than 15?
When the price is greater than 50.
Basically, when the 20% discount is on a higher value overall than the 10% discount.
But I'm still unclear. How do I gauge that?
No. So my question is not whether the second statement is sufficient or not. It's not at all related to the second question. I'm just asking a general question. In what circumstance, in general, would the overall discount percentage be more than 15? When this 20% figure
Is significantly
has a higher price?
Yeah,
Is what, sorry?
it's significantly higher compared to the other two items.
Or basically the sum of the other two items should be less than the single most expensive item. Right?
Yeah.
Basically, the price on this side should be more than the price on the other side, the overall price.
Yeah.
Okay. Now, are we getting that from the second statement? No, not at all.
No.
All we are getting is that one figure is 15. What are the other figures? Is the 20% wala price more than the right wala price or less? I don't know.
Yeah,
Both things are possible.
Yeah.
Yes. So the second statement alone is not sufficient. That much is done. Let's come to the first statement now. The regular price of the most expensive item. So this guy here on the left side, this one is $50. and the regular price for the next most expensive item was $20. So this much I know. Two prices I don't know. I know. I also know that the third price will be less than 20. Or okay, fine, for let's say less than equal to 20. This much makes sense, Namita?
Yeah.
So now, is this enough for me to figure out whether the overall percentage will be more than 15 or not?
Sure, I think, yeah, because we will be able to gauge with the $20 holistically if it's more than 15% or no.
Repeat that. I didn't get you.
So the price of the other two items would be equal to 20 or less than 20. So I think with the 50, and if we calculate different scenarios with taking into account 20 or less than 20 numbers, then we should be able to gauge with the first statement.
Fine. So to put that in slightly different words, basically the price for the two items combined, no matter what, will be less than equal to $40. And the price for the expensive item is $50. So the 20% discount is on the more expensive price. The 10% discount is on something less than $40. Therefore, the overall average will be closer to 20 than to 10. That means it will be more than 15. So statement 1 alone is sufficient. So what was your original answer, Namita?
So I wrote E because I'll tell you why. So when it said in the latter part of the first statement, the regular price of the next most expensive item, I felt that there's no clarity if this is the item which Henry is purchasing. So I had a comprehension issue. So I thought it's just talking about the items in the sale. I wasn't clear that it's talking about the item which Henry has purchased.
I see. So you just thought that in the store, that's the most expensive item.
Yeah. So that's why there was no clarity in the statements if this is what they're referring to, what Henry has purchased. So I thought they're making a generic statement, and that's why I chose E.
Okay, let's see that though. Henry purchased 3 items. He received a 20% discount off the regular price of the most expensive item. So doesn't that mean that the most expensive item out of the 3 that he purchased?
Yeah, I get this
Okay, you're clear
question.
now.
Yeah, I get the question, but what I was trying that, yeah, from the statements, what I'm talking was my comprehension issue.
Oh, acha. Okay, so
Yeah,
which
not
most
from the,
expensive item?
yeah.
I see. Okay, so that's where now this word "the" comes into play. So when they say the most expensive item, that means they're talking about some item that they've already mentioned earlier.
Yeah.
Right? So which most expensive item have they talked about? The one that Henry has purchased.
Yeah, got it.
Otherwise, then they would make it more specific, the most expensive item in the store.
Yeah,
Or
got it.
something like that. Okay, cool. All right. Thanks for sharing, Namita. Or batao, yeah, rest of you. Is it clear why the answer for this question is A, not C, not E?
Anish, just to get slightly more clarity, if we can just spend 1 minute, if in the A option it was $50 and the regular price of the next expensive was 30.
Yeah, that's a good point. Then what do you think? What do you think in that case?
Yeah, I just think we wouldn't be able to get that. I would like E in that case because
Ooh, careful. Not E. Double jump mark.
sorry. Yeah. Of course, two option. Second statement is
Yeah.
also there, so it gives us a value. Then we'll have to calculate exactly what the discount is coming to be.
No need to calculate. Okay, so let's do it actually. I like this. What are we talking about here? Give me a second. So you're saying that instead of 20, what if they had the figure 30 here? Correct?
Yeah.
So for the 20% side, the total price is 50. For the 10% side, the total price, can it be more than 50? Sure, it could be 30 plus 50 plus 25, for example. In which case, the price becomes more than $50, and then the overall average would become less than 15%. So we get a no answer. Now I'm thinking, can the price on the right be less than $50? Sure. The second highest is 30. The other one, for example, can be 10. So overall, I get $40, which is less than $50. In which case, the percentage will be more than 15. I get a yes answer. Yeah. So statement A alone would be not sufficient. The combination would then be sufficient. But I don't need to do any maths there. It's $50 on this side and 30 plus 15, $45 on the other side. I'm looking at the combination here. So 50 on one side, 45 on the other side. Overall, average would be closer to 20.
Yeah. Thank you.
No maths needed to figure that out.
हाँ.
ठीक है, sure. Batao, any other questions? Okay, sure. Let's continue. We dealt with this already. 3 kids, 10 chocolates, 6 kids, 40 chocolates. Right? One way I talked about already that the extra chocolates are 6 into 30, and then those get spread across 9 kids. So that's one way to think about it. Now, instead of first collecting and then redistributing, let me try to just ask the kids to distribute among themselves. How would that work? So let's just, for simplicity's sake, let me just call these kids rich kids, the ones who have 40 chocolates each. So each rich kid gives 10 chocolates to each poor kid. Then what would happen? Overall, there are 6 rich kids. So actually 2 rich kids will give 10 chocolates to 1 poor kid. Right? So the 3 poor kids will get 10 plus 20 more to overall reach 30. And the rich kids have given out how many? 10 chocolates each. And then overall the average becomes 30. Another way to think about it, basically, one rich kid is giving 10 chocolates, but each poor kid is getting chocolates from 2 rich kids. That's why each rich kid is giving only 10, but each poor kid is getting 10 plus 10, 20. Right? Think of it another way. If a country has more rich people and less poor people, and we say, oh, everyone needs to distribute money, fine, then the rich people will be like, okay, not that big a deal here. Overall, there are more rich people. So overall, if we all share the load, we'll be able to manage. Not a big deal. But if it's the other way around, let's say the country has, and let's take extreme numbers, a country has 10 rich people and 1 million poor people. Then the rich people will have to distribute money among all the poor people. Maybe they'll be able to give $1, $2 or some small amounts like that. And by distributing among all the poor people, they'll run out of money pretty much. Right? So here that we have more rich kids, it's easy for them, basically. The load on each rich kid is not that much. The load is getting shared by 2 rich kids for 1 poor kid. Right? Where's that coming from? I have double the number of rich kids. I have 6 rich kids. I have 3 poor kids. So 2 rich kids give 10 chocolates each to 1 poor kid. Problem gets solved. Another way to think about the whole thing is that the difference between the chocolates, 10 and 40, gets split in the ratio of, well, I can call it 1:2 or 3:6. Right? So 6 rich kids giving chocolates to 3 poor kids, or 2 rich kids giving chocolates to 1 poor kid each. Boils down to the same thing. So that's how then directly I can figure out the average. Directly from this difference. And it will take, I mean, it might take time, and that's fine. So the goal is not that within one day you should become experts and at just looking at numbers and figuring out the average. But if these steps become clear, then eventually, instead of every time thinking about excess and deficit, which by the way itself is also not a bad thing to do, but instead of even needing to do that, I can just think about how does the difference get split up. The difference between 10 and 40 gets split up in the ratio 1:2. So the difference of 30 gets split into 10:20. Now, each rich kid is giving 10 chocolates, so each rich kid gets left with 40 minus 10. Each poor kid is getting 20 chocolates, so they get 10 plus 20. Both ways, I get the same average.
Anish, just
Yeah.
a question. Don't you think that we should change the wording of the first sentence that each rich kid gives 10 chocolates to each poor kid? Because when I read it, I thought that 6 of them will give to 3 of them each.
Okay, to 1 poor kid. That's what you mean? That
Yeah, I thought
by
that
each you thought that
L of-
one person is giving to every poor kid, huh?
yeah,
Okay, okay, fair. This makes sense.
yeah.
Yeah, but I think was the point clear though?
Yeah,
That one kid is giving chocolates only to 1 kid, है ना?
yeah.
ठीक है. Fair. That's a fair point. All right. So the last point actually here. Who will get the bigger share when we split up 30 into 10:20? Who will get the bigger share? So one way to think about it, the rich kids will not have to let go that many chocolates because there are more of them. They will share the load. So they will not have to let go that much. On the other side, 1 poor kid will get chocolates from 2 rich kids. So he'll get kind of double the number of chocolates, right? From one rich kid here also, from another rich kid there also. So the rich kids will get a lot of extra chocolates compared with how much one rich kid has to let go of. Here, each rich kid is only giving out 10, but each poor one is getting 20. Right? So if you think of it that way, these people are getting, each poor kid is getting more chocolates than each rich kid is giving out. That's why overall, then the average comes to the middle figure. Middle of what? 10 plus 20 or 40 minus 10. Both are 30. All right. So let's add one more nuance now. If I were to just calculate the simple average of 10 and 40, that would be 25. Right? 10 plus 40 divided by 2, or the difference of 30 split into half, 15. 10 plus 15 or 40 minus 15. That's 25. That's the simple average. In our case now, the question becomes, will the average in this particular situation be greater than 25 or less than 25? We've already calculated it. So we know the answer is 30 and therefore greater than 25. But let's also understand why. Again, basically what I mentioned earlier, that each rich kid is actually not letting go of that many chocolates. Yet each poor kid is getting a lot of chocolates. That's why overall, the average would be more than 25. So this becomes a very important result. Just to understand on which side of the simple average would the weighted average lie. Would it be more? Would it less? That itself often helps us to get rid of at least a few incorrect answers. Chalo, let's try this question then. Let's discuss together. I need a volunteer. Or I'm going to ask Harshan up for a conversation.
Yep.
How did you find the question in the first place?
Fine. I thought of doing it through the other way, the ones we've been doing right now, but I was able to do it. I started getting into the formula based, and I just solved it like
Okay.
that. So,
Okay. Okay. All right. So what I need your help now with is this similar, actually identical question, but with different language. So let me first paint the picture. Let's say total there are 10 kids. The younger kids have 40 chocolates each. The older kids have 60 chocolates each. So we have younger kids, we have older kids. The younger kids have 40 chocolates each. The older kids have 60 chocolates each. The overall average is 56. Fine. How many?
Yeah.
What can we say now about the number of young kids and number of old kids?
There are more older kids than there are younger kids.
Right. So that's one thing. This number will be more than this other number.
Yeah.
Okay. Now, let's again think in terms of excess and deficit. So each older kid has 4 extra.
Yeah.
Each younger kid has 16 shortage.
Yeah.
Each, right? So how many older kids would we need to compensate for one young kid?
4.
This is important. We'll need 4 old kids to compensate for one young kid.
Yeah.
In other words, the ratio of old kids to young kids will be 4:1.
Yeah.
Now, what the number is, I don't know yet. But I know for every one young kid who has a shortage of 16, I'll need 4 older kids who have 4 excess each. This much makes sense?
Yeah.
So now we have actually 10 kids. Tell me then how many would be old, how many would be young?
8 and 2.
8 and 2. So now this is the first part of what the original question is also about, and I'll show it there. But at least on this screen, this much makes sense, yes?
Yeah.
Let me ask others also. Tell me, anyone unclear about what we've discussed?
Just one question. Why did we write 8:2?
So till here, were you with me that for each younger kid, we'll need 4 older kids to compensate?
Yeah.
In other words, the ratio of older to younger is 4:1.
Yeah.
And I have a total of 10 kids.
Yeah.
So if total kids are 10 and the ratio of older to younger is 4:1.
Okay, got
then how many?
got it. Yeah, got it.
Okay. Chalo. Let's now, Harshan, together do the same thing in the original question.
Yep.
What changed here from kids and chocolates, now we're talking about prices and fruits. So there are apples, which are 40 cents each, and there are oranges, which are 60 cents each. Again, the overall average is 56. I don't know how many. But the same logic again.
Yeah.
There's 4 cents extra. each for each orange. There's 16 cents deficit for each apple. So we'll need 4 oranges to compensate for 1 apple. In other words, oranges to apples becomes 4:1. Again, which means 8 and 2, 8 oranges and 2 apples.
Yep.
So this is 1/2. We're not done yet. Tell me then, what's left, Harshan?
Now to bring this down to 52, then the excess that we have is 8 and 8 and how much? 12. So then
Nice. Yeah.
then just 8 and 12 is
Let's do it together. So 52. Excess is 8 cents. And the deficit is 12 cents.
yep.
Then what?
Now total originally we had 8 oranges and
Yeah.
8 and 2, so we had 10 total.
Yeah.
Right now we have this 8 and 12 is 2 and 3. So from
Hold on. What is 2 and 3? Number of apples and oranges.
no, I mean the ratio of 8 is to 3
ratio. Yeah.
is 2:3. So
Nice.
the girl gave back 2, so that 4 oranges went to 2, and that 1 apple went from 1 to 3. So then the ratio.
I lost you here.
Basically,
So-
the ratio changed from 4:1 to 2:3 to maintain the new average, right? So when it was 4:1, the ratio was 56. Now when we want 52, the ratio is 2:3, right? So how many oranges did you give back? You gave back 2, and the total fruits then basically apples went up by 2 and oranges came down by 2. That's what.
No, now there's a issue of understanding what the question's asking for. How many oranges must Mary put back? So now see, here it's not like Mary is giving something to somebody else, or oranges are doing something with apples. Apples remain the way they are. All that's happening is the number of oranges is going to reduce.
Yeah.
Oranges are not going to convert into apples or anything like that. That makes sense?
Yeah.
So, to understand another way, let me get rid of that initial portion actually. So what we have got after dealing with that initial portion, that 56 cents average we get when we have 8 oranges and 2 apples. Let me ask again, anyone unclear about how we got 8 oranges and 2 apples for the average of 56 cents? Okay. So what's the situation after that? Again, we're dealing with apples and oranges. Apples are 40 cents each, oranges are 60 cents each. The overall average now has to become 52 cents. And what's the question? How many oranges must Mary put back so that the average price of the pieces of fruit that she keeps is 52 cents? So all the fruits that she keeps, their average needs to be 52 cents. The only thing she's doing is she's returning some oranges. Harshan, what's she doing with the apples?
3. The total number is now 5.
Now, एक minute. What is she doing with the apples? Let's start with that.
Nothing.
So how many apples will she have?
She'll have 2.
2 apples. Right. This figure we don't know yet. Now, in terms of excess and deficit, how much shortage is there on the apple side?
12, right? 24 total.
Right. 12 per fruit. Overall, 2 fruits. That's a shortage of 24 cents. 24 cents shortage. This much needs to be compensated on the other side.
Yeah.
The other side, the excess per orange is 8 cents. 8
Yeah.
cents times how much is equal to 24? That becomes the question.
Yeah.
So then that how much is essentially 3.
Yeah.
Right? So the number of apples and oranges that this person should be left with such that the overall average is 52 is 2 and 3. So what should be the answer now, Harshin?
3 oranges.
Read the question again.
How many oranges McMahon put back? She had. Oh, sorry, 5.
Yeah. How many must she put back?
Yeah, sorry.
She originally had 8. She has to put back 5 so that she's left with 3.
Yeah.
Yes. That's why the answer is 5. So, fairly complex question, right? Probably the most complex one we've seen yet today. So many layers getting added up, one on top of another. But if we go about it one by one, apart from obviously making not understanding exactly what they're asking or what's given, if we go about it systematically, we can tackle it still based on what we've discussed today. But yeah, just the fact that there are so many layers itself makes the question fairly complex. But Harshin, clear how we first dealt with the 56 cents, then the 52
Yes.
cents?
Yeah, I got confused with keeping the number of fruits same. That's why I went down the ratio path. But yeah.
Yeah. So it's not like we are reducing oranges and increasing apples.
Yeah.
Right? In fact, we are maintaining the number of apples constant and just reducing oranges. That's the only thing we are doing. Yeah. Also, just keep in mind when you were talking about ratios, make sure you're using the right direction. 2:3 versus 3:2 are different things. So just make sure that whenever you're thinking in terms of ratios,
Yeah.
you're clear about what's the left term, what's the right term. ठीक है, चलो और बताओ, everyone else, questions, comments? If it's clear, tell me in the chat. Okay. All right. Let's get into mixtures now. Again, I'd like to have a conversation with someone. A very small group. Kanav?
Yes,
Am I pronouncing your name correctly, by the way? Kanav ya Kanav?
Kanav is fine.
Kanav is fine. ये थोड़ा सा dicey answer था. मतलब, if I asked you what's your name, what would you say?
Kanav.
Okay. All right. ठीक है. चलो. Do you drink alcohol?
No.
No. But I don't also. But tell me if you can understand what we discuss.
Yeah, sure.
So, I mean, some of your friends, I'm guessing, drink. Fair?
Yeah.
ठीक है? तो चलो, we are going to discuss whiskeys.
Great.
Have you seen anybody like, let's say a friend makes a glass of whiskey for another friend, and the person just looks at the glass and the person like, "Arey yaar, this is too strong. Make it more diluted. It's
Yes.
too strong," है ना? Without even taking a sip.
Yeah.
How can they do that?
Color?
Color. What about the color?
I mean, I guess they can tell if it's too dark, then it's strong.
Right. So let's say a person wants a whiskey with only mixing it with water, nothing else. So just by looking at the glass, people obviously who have experience with it can tell, "Arey yaar, the color is very dark brown. That means the quantity of water in the glass is very little, there's a lot of whiskey only in the glass.
Yes.
Similarly, on the other extreme, if the color is very light brown, then the thought would be, oh man, this is too much water, this is too diluted.
Correct.
Right? So now this much we understand at an intuitive level. That's what is needed for, at least as a starting point, that's what's needed for mixtures also. Just this intuitive understanding.
Right.
So if I add more water, the color will move from the center towards colorless. If I add more, if the quantity of water is more than whiskey, then the color will be lighter.
Correct.
If the quantity of whiskey is more, then the color will be darker.
Yeah.
Right? Let's say there's a spectrum overall, all the way from dark brown to colorless.
Yeah.
And we have that middle line.
Hmm.
If whiskey increases, then the color will go towards the left, towards dark brown. If water increases, color will go towards colorless.
Yeah.
Anyone to whom all this is unclear? Or any of this?
Yeah, just one, that if they are drinking another liquor which is also same as water, then they will not be able to use this chart to determine if it's strong or not. Like
Basically,
vodka or something.
some alcohol is also colorless, you're saying.
Yeah.
हाँ, वो तो है ही, vodka वगैरह डाल रहे तो गड़बड़ हो जाएगी.
Yeah.
That's true. हाँ. But chalo, we are keeping it simple. The goal is not to scam somebody, but just to understand mixtures.
Yeah.
So now let's say I have two glasses. One glass already has whiskey in it and some water also, which is roughly at this color. Another glass is somewhere here on the spectrum. Right? I'm not getting into figures yet. No percentages, no figures. But basically, both glasses have whiskey also and water also. The glass on the left has more whiskey, less water. The glass on the right has more water, less whiskey. And if I mix the two glasses, then what will happen? What kind of color will I get in the result?
Somewhere in the middle of those two.
Where exactly in the middle?
We can't tell.
What would that depend on?
The quantity of which glass is more.
Right. So let's call them glass A and glass B. So now within this shorter spectrum, within this smaller spectrum, if quantity of A is more than quantity of B, then the color will be to the left of the center.
Yes. Yes.
Right? If the quantity of B is more than quantity of A, then the color will be to the right of the center.
Correct.
Same principle again.
Yeah.
Achha. Is there some combination? Can I mix A and B in some such way that the overall color becomes darker than A also?
No.
No. Similarly,
No.
can I mix them in any way that the color becomes lighter than B?
No.
That can never happen. No
It will be
matter
in the
what,
middle.
it will be in the middle only. Exactly where in the middle will depend on in what ratio they are mixed. But it will definitely be in the middle only.
Yeah.
So can you already maybe see some parallels with what we have discussed since morning? Averages में भी तो यही चलता है. Average will be in the middle only.
Yes.
Exactly where in the middle will depend on how many kids on this side, how many kids on that side.
True.
Here we
Yes.
talk about quantities.
Yeah.
So essentially mixture.
The rich kid, poor kid.
Yeah, exactly.
Yeah.
Exactly. ठीक है. So now when I'm talking about glasses, to get slightly mathematical now, all alcohols, for example, have all bottles have a percentage alcohol mentioned, right? Beer has this percentage alcohol, whiskey has this percentage, or this whiskey has this percentage alcohol and all that. And plus, if I'm anyway adding water also, So let's say, for example, this glass on the left overall has 20% alcohol and 80% water. This
Okay.
glass on the right has 10% alcohol and 90% water.
Okay.
So first of all, this percentage notation, Kanav, that's clear?
Yeah, 20% and 10%.
Anyone else to whom this percentage notation is not clear? What 20% alcohol means or what 10% alcohol means? Okay, so when I mix these two, we talked in terms of colors. Now tell me in terms of percentage, Kanav. What's the spectrum? What would be the result percentage of the resulting mixture?
If the quantity is the same, then 15%
Nice,
alcohol
nice.
and 85% water.
Yeah. If A is more than?
If A is more, then it is more than 15%. If B is more, then it's closer to 10%.
Indeed. Can the overall percentage ever be more than 20% by mixing A and B?
No.
Can the
Even
overall
if
percentage?
no, even if we mix 100% of A, it will still remain 20, even if there's no B.
Exactly.
But
Exactly.
yeah,
Can the overall percentage be less than 10%?
no,
No. And it will definitely remain in the middle only.
correct.
So the same discussion we had with colors earlier, now we're having with percentages. The basic
Yeah.
idea remains the same. Okay. So this understanding now will act as the base for mixtures questions. While we still will need to do maths, we will need to discuss things. But anyway, at least these basic things should be clear. That no matter what, the resultant mixture will have a percentage in the middle. It can't be on the left or the right of the extremes. And on which side will it go? It will depend on which quantity is more. ठीक है, chalo. Thanks for this, Kanav. Let's get into a question and then again we'll discuss after that. ये हो गया. Chalo. Why don't you go through this question then? Let's discuss. If you're still at it, let it be. Let's look at it together. So a couple of things to notice initially, even before we get into solving. One, the examples that we discussed earlier, the discussion I had with Kanav, we were talking about liquids there. Here they talk about a seed mixture, not liquids. So that itself, does that make a big difference? We're looking at solids instead of liquids. That doesn't make any.
Yeah, I didn't
Right.
consider also.
Okay, that's one thing. Now, next, notice here overall they have 3 seeds or 3 items mentioned, right? There's ryegrass, there's bluegrass, and then there's fescue. So how do I tackle that? It's not like it's ryegrass, bluegrass at both places. And the ryegrass is there in both of them, and then they've mentioned that the resulting mixture also contains 30% ryegrass, so that's good. But the other component is different in the 2 cases. So how do I tackle that? Does that even matter? Do I need to do something specifically about it? So let's understand that first. Let's say now, back to the alcohol example. Let's say there's one glass with 40% alcohol and 60% water. There's another glass with, what's the other figure? 25% alcohol and 75%, not water now, let's say Coke. Then when we mix the 2 liquids, we get a resulting cocktail, a very weird cocktail, which would have alcohol, Coke, and water in it. But no matter what, essentially the alcohol component will be between 25 and 40 only. Exactly where it will fall will depend on in what ratio they are mixed. And then the remainder would be water plus Coke. Fine. But the alcohol will be between 25 and 40%. Right? That's not going to go anywhere. So even if the rest of the portion is different, doesn't really matter. So here also, for example, in the mixture, 30% is ryegrass. The remaining 70% will be some combination of fescue and bluegrass. Fine. But as far as my calculations are concerned, whether this other element is the same in the two cases or different, that doesn't matter at all for my purposes. What matters is everywhere ryegrass is the same. So I'll focus on that. 40% ryegrass in the first one, 25% ryegrass in the second one, 30% in the mixture. That's the only thing that matters for me. So I do not care about the third component or the second component in the two cases being different. Okay. So now essentially the question boils down to, we have one mixture which has 40% ryegrass. We have one mixture which has 25% ryegrass. The combination has 30% ryegrass. Now this is where it gets slightly more interesting. What percent of the weight of the overall mixture is X? So I don't know these two components. So let's just call it small x and small y. They're asking us X upon total as a percentage. That's what I have to figure out. So how will I get total from X and Y? Well, X upon X plus Y percentage. But how can I figure out the values of X and Y? I actually can't. But I can figure out the ratio of X's to Y. And that will be enough to calculate this. Right? Even if X and Y get multiplied by the same factor, this whole X upon X plus Y will still, the extra factor will get cancelled everywhere. So now I'm clear that for this question, to answer this question, I need to figure out the ratio of the two mixtures, the ratio in which the two mixtures are mixed. First things first, 40 and 25. The exact average is 32.5. So if they were mixed in equal quantities, then the overall average would have been 32.5, the simple average. In our case, the average is less than 32.5. Therefore, which one would be more? The 40% mixture, capital X, or the capital Y? Which mixture would be more?
Capital Y.
Capital Y, yeah. So, if nothing else, I can at least get rid of these two answers. They've asked for what percent of the weight of the whole mixture is X. It will be less than 50% because the other component will be more. Remember, X upon total, not X upon Y. That's what we need here. So less than 50%. Now, how do we figure that out? Again, let's go back to what we've been doing earlier. The only difference here now is that we have some percentage signs, but the basic point remains the same. 10% extra each, and then 5% shortage each. So 10 into, let's say, X equals 5 into Y. Sure, I can maintain the percent symbol also. Doesn't really matter, right? Divide by 100 will cancel. So 10x equals 5y, or x upon y equals 5 upon 10, or 1:2. And then the total x upon x plus y becomes 1 upon 1 plus 2, which is 33.33%, 1 by 3. B is the answer. This ratio that we figured out here is essentially the ratio between the differences. The difference between 40 and 30 is 10. The difference between 30 and 25 is 5. So that 10 and 5, That's the ratio between x and y. Right? This component here will be 5 parts. This component here will be 10 parts. Because 5 into 10 needs to be equal to 10 into 5. B is the answer here. Okay. 2 more questions I want to cover today. Let's try this one then. Chalo, let's discuss, huh? Abhinav, up for a conversation?
Yes, Anish.
How did you find this question?
It is manageable, but I don't know where I'm going wrong.
First of all, notice this. You could not manage it. Right? I'm using your thing. Yet you are calling it manageable.
I mean, it can be done. I mean, just due to the time constraint and all. I mean, think I'm a bit stuck somewhere.
So, okay, 2 different things. One is that if you had more time, you were on the right path, you would have continued and got the answer. The other is that you are stuck.
Yes.
So is it that you were stuck or you were going smoothly, just that you needed more time?
No, I'm stuck.
Yet you're calling it manageable. Again, see, this is not a dig at you, but I see this so many times. Right? People are like, I've seen in mock tests, people taking 5, 7, 8, 9 minutes on a question, not moving on. Why? Because they have told themselves, "Arey, it's an easy question." They're not getting the answer. They're stuck. But, oh, it's an easy question. I can't afford to miss this. So that's quite interesting. Think about that. Where does that definition of what's easy, what's manageable even come from? Chalo, anyway, tell me then, where were you stuck? Or how did you start? Let's do that.
So basically, what I'm trying to find out, the average percentage of protein. Basically, that is where I got stuck. I mean, it says 38 grams of protein daily, right? So this 38 grams of protein. Should I infer it from the total of 300 grams, or how? I think this is the place where I'm stuck.
Oh, okay. So let's read the question again. A diet contains 300 grams of a mixture of 2 foods, X and Y. So how much is the weight of the diet? 300 grams. Food X contains 10% protein. Food Y contains 15% protein. If a diet provides exactly 38 grams of protein daily, so what's the weight of the overall diet?
300 grams.
300 grams. Out of that 300 grams, 38 grams is protein. Then what's the percentage of protein?
12.6%.
Basically 38 upon 300, no?
Yeah, yep.
Yeah.
Yeah, so I found it 12.6. I have it on my notebook.
I thought you were stuck here. I thought you weren't clear about.
Then I think there's some calculation error or something. Because 12.6 I have it here.
12.6. 12, 2 by 3. Right. That's what we have. Okay, then what did you do?
So then I got a ratio of 3:2.
Between
15, 12.6. I just took an the estimate, which is I didn't consider 12.6.
That's the issue, nah?
Yeah,
it's actually 12.666.
Correct. So I think this is
that's why you got. Yeah. See, the question, how many grams? They don't use words like approximately, roughly, or anything like that.
Correct.
Plus, at least these 2-3 options are fairly close to each other. Right? Sure, 100 is far apart, 160, okay, far apart, but these 2-3 options are close. So even that difference could impact how things go up, how we handle things. But tell me one more thing. Overall, if the two if the two foods were mixed in an equal quantity, Then question enough. Abhinav,
Yes.
you got my question? Percentage terms में बताओ. If the two foods were mixed equally, what would be the percentage of protein in the resulting food? 10% protein, 15% protein. If I mix them equally, what's the percentage?
Okay. 12.5.
12.5. Right? If they were mixed equally.
Correct.
For 300 grams, 12.5% would mean in grams how much protein?
Approx 37.
Right. How would we calculate it? Tell me that much.
So I just basically did the math. 50%, 150, 150, and half 25%, which is 75, 75 has 37.5.
I couldn't follow you, yeah. So 12.5% of 300, we would do like this, right?
Yeah.
So then zeros get cancelled. 12 into 3 is 36, plus 0.5 into 3, that's 1.5. Overall, we get 37.5. Now, in our case, actually, we have 38 grams.
Yes.
Had they both been mixed equally, then the protein in the overall mixture would have been 37.5 grams. In our case, the protein is slightly more. So two things. One, food X will be roughly half only then, because this protein is actually so close to the exact half. Which side will it be on? Food X will be little bit more than half or little bit less than half?
I think it will be between because 12.5.
So see, this is where we are. Let me assist you a little bit. Had the two quantities been equal, then the protein would have been 37.5. Is that much okay?
Yep.
Anyone unclear about this point? Had the two quantities been equal, the protein in the overall mixture would have been 37.5 grams. Okay. Now, what's happened in our case? The amount of protein is slightly more. In other words, in terms of percentage, Abhinav, is the percentage slightly more than 12.5 or slightly less than 12.5?
Slightly more.
Slightly more?
Yep.
Right? Exactly how much? वो तो तुमने actually anyway calculate कर लिया था. 12.66. Slightly more than 12.5, which we can see through this also, right? Slightly more than 37.5 grams.
Yeah.
Therefore, the food with more protein will be slightly more than the food with less protein.
Right.
Food Y will be more than food X. Which means food X will be less than half of the overall mixture. You get that?
Yes.
So which options can we already reject?
A, B, and D, which you want. Also the D.
A and, sorry?
A, D.
A, D. Not B, not E, but also remember the proteins are actually so close to exactly the middle. I'm thinking that even 100 is too small.
Yeah, correct.
So if nothing else, at least just by this much, I can get shortlist to 2 answers. I'll probably still need to do the maths, but at least till this point I could get just by understanding these things. Again, my starting point was, let me start with simple average. Using the simple average, then I thought, in our case, the weighted average is more than simple average. What does that mean? That means the food with more protein is slightly more. Food Y is slightly more than food X. In other words, food X is less than half. Yeah, all this makes sense, Abhinav?
Yep. Yes.
Okay, chalo. So up, there are 2 ways to deal with the question. One is, I can convert everything into percentages. But as you also saw, this percentage 38 divided by 300 in 200, that's a weird decimal or a weird fraction. It's not a clean number. So then I'm thinking, instead of converting everything into per 100%, maybe I just keep everything in per 300. Overall, they just need to be proportional to each other. Right? Either I do 10%, 15%, and then 38 also I convert into percent. Or I look at the middle as 38 grams in 300 grams. And then for food X, 10% means 30 grams in 300 grams. For food Y, 15% means 45 grams in 300 grams. And now I have to figure out how much X is there, how much Y is there. Does this make sense, Abhinav, that instead of just converting everything into percentages, I can keep everything at per 300 also? They're all proportional.
Yes, correct.
So, ab batao, on this side, there's a shortage. How much is the shortage? 8 times whatever that X is. On this side, there's excess. How much excess is there? 7 times Y. So then, what is X upon Y? 7:8. And then, basically, overall, we have 300 grams. This 300 will be split into 7 parts and 8 parts. So how much is that? 300 upon 15 times 7. So that's 140 and 160. The question's asking for how many grams of X are in the mixture. This one is X. So 140 becomes the answer. Abhinav, make sense?
Yes, correct.
So had you taken the exact percentage, 12 2 by 3, then you would have also got the right answer. Converting that into 12.6, I think, made it difficult.
Yeah. So I just made an assumption kind of. So basically when I saw a decimal, right? So I thought this is going to get cumbersome. So hence I just considered it as a 12. So that is where the things
Oh,
went wrong.
12 only, not even 12.6.
No, basically, yeah. So basically, just to get rid of the decimal, I could have converted into basically proper fraction, or else
Yeah.
I would have considered the same number.
Yeah. So see, now in some cases, even I round off like that. Why didn't I round off here? Because like I mentioned earlier, there's a few answers that are quite close to each other.
Yep.
Right. So even that small percentage difference, anyway, because we're looking at 300
I
grams.
was also getting around 130, and also I was like, but it's not in their option.
Yeah.
How am I getting that? So I think that number makes a difference.
Round off karna bhi hai, to I would have rounded off to 13, not to 12. 12.66 is closer to 13 than to 12, right?
Right, correct, yeah.
Or maybe 12.5 you could have considered. I'm not sure what answer that would lead. But yeah, anyway, one way is to take the exact fraction, or I find that this is just easier. Keep the 38 as it is.
Yeah, makes sense.
Okay. All right, tell me, rest of you, questions?
Okay, Anish, I did it
Yep.
the same way, where instead of doing it in this excess and shortage part after step 2, where we narrowed it down to B and E, I just plugged in and just calculated quickly what the which is adding up correctly.
Interesting.
Now my question is, right now it was easy because it was just a difference of 145 and 140, so the calculation was still relatively easy. But in the situation where it's not, the answer choices are even closer or in some other form, is there a way to plug in, when should we think of plugging in and when should we think of doing the full thing like this, shortage and
So
excess?
tell me, when you were left with 145 and 140, what did you do next? Exactly.
I
How
plugged in. I knew that it was less than 150 each, so 145, 140, and then I just did 140 into 10%, so that's 14, and 160 into 15, that was 24. That worked out to 38 exactly. So just selected E then. It's 24.
Okay, so overall, this plus this is 38 grams.
Yeah.
Fits. So your question, so now, but what I don't get is, let's say this one is 140 and there were another option 141. How would that have mattered?
I mean, because the exactly 38 grams of protein is in the mixture,
Yeah.
14.1 would have been here, and then that would have been, it might not have come exactly to 38. That's why I wouldn't have started with 141. I would have started with 140.
So what I understood, and maybe I misunderstood, what I understood your question was, what if the other options are also close? Whatever options
Yeah.
are left, what if they're all close to each other?
Yeah. When should we think of plugging in? When should we think of doing the full? Yeah.
So let's say these are the three options left.
Yeah.
So even now we can plug in. So what if they're close? Two things. One, like you said, anyway, the question saying the diet provides exactly 38 grams, right? So after I do my calculations, the resulting protein should be exactly 38.
Yeah.
So if it's even 37.9, it's wrong. Even if it's 38.1, it's wrong. That's one thing. Second, now again, like you also said, I would start with the easiest value. Right?
Yeah.
140 is round figure, nice round figure, easy to calculate 10%. 160 also easy to calculate 15%. So basically how I dealt with 140 is not getting influenced by what the other options are, whether the other option is 145 or 141 or 139.
Got it. Yeah. Okay.
So to answer your question, even I do this. If I'm able to logically get rid of 2 or 3 answers, I'm only left with 1 or 2. It's a great stage to plug in answers. Because let's say like you're left with 2 options, you plug in 1. Now, of course, it depends. One assumption here is that you are confident about all your calculations. But let's say you're left with 2 options, you plug in 1. So either that one will be correct or the other one will be correct.
Yeah.
Right? So you don't even need to try the other one then. Like
Mhm.
I said, though, assuming that you're confident about your calculations.
Yeah.
But I would definitely plug in. I mean, I can't think of an exception, but yeah, usually I also plug in when there are 2 options left in the end like this.
Yeah.
Did I answer your question?
Yeah. 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 Thanks.
Okay. All right. Or batao, questions? Okay. So I'll share one question now that you guys can work on and we'll discuss tomorrow. Here. You can do one thing actually, take a screenshot. Yeah, you can try it yourself later. I'm assuming you would be done by now. So be sure you try it. Then we'll discuss it tomorrow. Chalo. Let's wrap up. Tell me, what have been your takeaways?
One out of these mixtures part is good to estimate the sort of middle points and the middle values, and then work around the options, lower, greater, shorter type.
Yes. While I started discussing that today, we'll do more of that tomorrow. Yes, in fact, in a lot of average questions, average and mixtures questions, my starting point is, okay, if it was just simple average, what would it be? In our case, what's going on? And what does that mean? Right? Which side is more, which side is less? Yes, I do find that's very helpful. Also in line with what I mentioned in the morning, that answer choices are a resource. So why not use them? If I can get rid of 3 options within 10-15 seconds, definitely worth it. Yeah, makes sense. So we'll continue to build
Hi,
from this.
Anish.
Yeah,
Hi,
hi.
Anish.
Go ahead.
Just wanted to share one takeaway that this idea of keeping 300 as a base was new for me, so it was pretty helpful in other questions as well, probably. So this was something I've never done before, and I've already given GMAT one time. So I've done one round of full preparation, but still I never came across this method.
So is it clear why I was able to? You're talking about the last question we did, right? The protein one.
Yeah.
So is it clear why we were able to do that?
Yeah, because doing it with hundreds or with percentages wasn't giving us a whole number. So
Well, that's
and
one reason.
the options
But
were
why?
close by 140, 145. So
But why? I mean, why was it okay to look at 300?
why was it okay? Because we were given 38 grams. So
So
I mean,
essentially, because the proportion remains the same. If I'm looking at per
yeah,
100 at every place or per 300 at
per
every
300.
place,
Yeah,
means the same thing.
exactly. Yeah.
That's why we could do it. And
Yeah.
you're right. Because those numbers were easier to deal with, then I'd rather do that.
Yes, and also the morning question was left for discussion. We
Kaun sa?
were supposed to discuss it.
Kaun sa? The 22 men, 26 women?
Yeah.
Did you join
We
late?
did- no. Yeah, we discussed it. Yeah. So just so many things have happened. I forgot about. Yeah.
I could be wrong, but I think that was the question I'd given in the end.
Yeah. Actually, we started with some other smaller questions. So and then
You're
we
right.
came to
You're right. Yeah. But yeah, we did cover that.
Correct.
ठीक है, cool. सही है. Thanks for sharing. और बताओ भाई, takeaways.
Anish, not a takeaway, just a separate logistical question. Out
Yeah.
of the in the newer format now, out of the data insights, the DI section, how many are approximately the sufficiency ones, the DS ones? Is there any range?
That's a good question. Yeah, all I know, I've taken 2 practice tests. I remember in the first one, I had 8 DS questions. I don't even remember the number of the second one, but I definitely don't have an idea about the range.
But 8 out of whatever, 23, 25, right?
No, 8 out of 20. Data
20.
Insights has 20 questions.
Yeah, so close to half at least.
Well, that's what I had in my first test.
Okay.
So is it representative? Is it always the case? I don't know.
Okay.
But definitely, I think more data sufficiency questions compared with any other question type.
Compared to the graphs and
exactly, they're not evenly distributed.
Okay. Thanks.
Yeah.
Anish, I also had a question. So just to understand, in terms of what you'll be teaching in these 3 sessions, would that be exhaustive enough for us to at least get the fundamentals, or will we have to refer to something else as well?
Exhaustive for the fundamentals, I believe so. Yeah. Did I answer your question?
Yeah.
Baki, see, it also obviously depends on how well you're understanding these things. If anyway the things we are discussing are not clear, then anyway it won't be exhaustive. So there is
True.
subjectivity in that regard. But in terms of basic concepts, basic things that are tested, I have tried to cover a range of questions that you come across. So as far as fundamentals are concerned, I think yes, we'll cover all.
Got it.